Excuse me.
শুধু একজন তুমি।
তাই?
লিঙ্ক পাঠিয়েছিলাম। আসছে। শেয়ার স্ক্রিন করে। শেয়ার স্ক্রিন করছি।
কত হয়েছে? Hello everyone. Hello everyone. Can you hear me? And can you see the screen properly? So for biological oxygen demand or BOD, it is that water becomes polluted by various dead matters or organic matters which gets deposited in the rivers, lakes, ponds, etc. So various organic matter like the dead living plants, animals and fishes, so many things gets deposited in the water bodies, and the bacteria which is present in the water starts decomposing those organic matter. Now bacteria lives on the oxygen which is present in water. The oxygen which is available in water is known as dissolved oxygen. So when the amount of the organic matter in the water bodies increases, the number of bacteria also increases as it can get the food and grows in the number, and thereby they start absorbing or finishing all the available oxygen which is present in the water. So in this way, when due to the polluted matter or polluted particles or the organic matter. Here it is specific. When we are discussing the biological oxygen demand, it is important that we understand here we are not considering any kind of chemical compound or chemical waste. We are only considering the organic matter which is present in the water body. So, biological oxygen demand is a measure of the oxygen used by the microorganisms to decompose this waste. Whatever waste is there, microorganism is decomposing the waste and thereby finishing the oxygen. And when the amount of the dissolved oxygen in water decreases, the aquatic life starts dying, or they cannot survive, like fishes and various aquatic plants. They cannot survive as the amount of the dissolved oxygen decreases in the water body. So, a large quantity of organic waste in the water supply guarantees a large number bacteria present to decompose this waste. So, in this case, the demand for oxygen will be high due to all the bacteria. So, the BOD level will be high. As the waste is consumed or dispersed through the water, BOD levels will begin to decline. So, what is a BOD? So, BOD can be defined as the amount of oxygen required by the microorganisms to oxidize biologically oxidizable impurities present in 1 liter of wastewater sample for a period of 5 days at 20 degrees centigrade. So, BOD determination requires 5 days of time, and the temperature should be maintained at 20 degrees centigrade. This is important. And the microorganisms which oxidizes only biologically oxidizable impurities or biologically oxidizable pollutants which is present in the water body. So, what is the amount of oxygen consumed by the microorganisms to oxidize the biologically oxidizable impurities for 5 days of time at 20 degrees centigrade? An amount of wastewater should be taken 1 liter. So, that is called biological oxygen demand. So, why BOD is important? It is important in sewage treatment because when you are getting the sewage water, one parameter we measure is that what is its BOD. By calculating the BOD, we can understand that how much pollutant the sewage water is, and as it indicates the amount of decomposable organic matter in the sewage. Greater the concentration of organic matter in the sewage, greater is the BOD. And the unit of BOD is expressed in mg per liter or ppm. ppm is parts per million, ppm of the wastewater sample. So this is BOD, and how the BOD increases. If the nitrates and phosphates in the water body is high, then BOD is also high, because nitrates and phosphates, they are the nutrients. These nutrients also add on to the increase in the amount of the microorganisms in the water body. So if there is number of microorganisms increasing, there is decrease in the dissolved oxygen and increase in the BOD levels. Nitrates and phosphates are plant nutrients and can cause plant life and algae to grow quickly. And unnecessary plant and algae, if it develops in the water body, that also decreases the amount of dissolved oxygen. When plants grow quickly, they also die quickly. So as many number of plants are growing in a pond or in a lake, it has a some lifetime, it dies, and then the decomposition of this kind of organic matter starts. This contributes to organic waste in the water, which is then decomposed by bacteria, resulting in a high BOD level. So there should not be nitrates and phosphates in the water body. Nitrates and phosphates are discharged in the water body from the fertilizer, mainly the source is fertilizer. So this is about BOD, and you will have to remember the definition of BOD and importance of BOD, its unit, and all that. So now it is chemical oxygen demand. As you have now understood that BOD is only concerned for the biological oxygen demand or the biological waste. But in water there are like sewage water. Sewage water is not only the plant bodies and the dead bodies of the animals and all organic matter. It can be industrial pollutants also, then drainage, soaps, detergents, so many things. So what about the chemical compounds? So how they will get decomposed? What is the fate of that? So for that reason, there is another parameter developed which is known as chemical oxygen demand. So what is chemical oxygen demand or COD? COD of sewage is defined as the amount of oxygen required for the oxidation of biologically oxidizable, that is the BOD part, biologically oxidizable, and biologically inert impurities, that is purely chemical compounds, biologically inert impurities present in 1 liter of wastewater using strong oxidizing agent like acidified potassium dichromate. So it is again, and there is a COD process or determination of COD is a quick process, doesn't need kind of 1 day or 2 day or 3 days. It quickly in a day only, in few hours you can determine COD of the wastewater, and you will be able to evaluate that how much oxygen deficient the water is. Or COD can also be defined as the total amount of oxygen required to chemically oxidize the biodegradable and non-biodegradable organic matter. Biodegradable are the biologically oxidizable, non-biodegradable are purely chemical compounds. So when all the impurities we take into consideration and their oxidation process is evaluated, then we calculate the COD. Okay, now it is the part that how to determine, this is an experiment, how to determine COD of wastewater. It is there in your syllabus. We are not conducting, but civil engineering department higher semester they are conducting. First year syllabus also this experiment is there. So what is the process of determination of COD in wastewater sample? So obviously some sewage water or wastewater sample will be provided, and this sample of water, a particular amount of or particular volume like either 10 ml or 25 ml or 50 ml of the wastewater sample is refluxed in strong acidic solution with a known excess amount of potassium dichromate. So this sample will be dissolved with or mix with the acidified potassium dichromate. And how much potassium dichromate we are taking, we must know it, that this is the volume of the potassium dichromate. And all of you know that acidified potassium dichromate is oxidizing agent. Remember, oxidizing agent. So this is all about the oxidation of the pollutants which is present in the wastewater. Now I have sent you a link, YouTube link. There you will understand what is the process of refluxing. So refluxing is refluxing we can carry out in a round bottom flask. In that round bottom flask, one water condenser is attached. You can see that video and you will understand the long pipe which is attached to the round bottom flask. It is the reflux condenser. So in the reflux condenser there are two pipes, one for inlet of water, another for outlet of water. So in refluxing what happens, whatever volume of the solution or any liquid you are taking, that volume will not be reduced If you are heating that solution for 1 hour, 2 hour, or for the whole day, the volume of that liquid will remain same. So that is called refluxing. Otherwise, normal boiling, what happens? Any liquid gets evaporated. That's why it is the difference. It is not normal boiling, but it is the refluxing. So water sample is refluxed. Wastewater sample taken mixed with acidified potassium dichromate, and then and this is put for refluxing. And after here also we'll have to add some reagents in the solution. That solutions reagents are silver sulfate and mercuric sulfate. So the principle is that after refluxing, some of the potassium dichromate will be consumed for the oxidation. Okay, and some of the potassium dichromate will remain as such, as unused. So what is the amount of potassium dichromate unused or not used for oxidation should be estimated. So how it is estimated? It should be titrated against ferrous ammonium sulfate solution. So titrant in the burette is FAS solution. In the conical flask, there will be uh, unreacted, or unreduced or unused potassium dichromate. So from the titer value, we will be able to calculate what is the COD value. So here the procedure is like this, that wash a 300 ml round bottom flask. You have seen that refluxing flask, it is called round bottom refluxing flask. In that flask you can add 10 ml of either this volume differs. Okay, it can be 10 ml, it can be 25 ml, any. So 25 ml of or 10 ml of the wastewater sample should be taken. It should be mixed with, if it is 10 ml sample, should be mixed with 5 ml of potassium dichromate and 15 ml of concentrated H2SO4 along with little. Here instead of one spatula we can say add about 1 gram of mercurous sulfate. Okay, and then again round about 1 gram of silver sulfate should be added. Okay, this will enhance the refluxing process. Then shake well and reflux for 2 hours. So the whole solution should be boiled for 2 hours. So it is not normal boiling, boiling through refluxing for 2 hours. Let the wastewater and the potassium dichromate react and allow the potassium dichromate to oxidize the oxidizable pollutants present in the wastewater. So after 2 hours, you will have to stop the process or stop the heating. Then take out the solution, cool it and add little amount of distilled water to the flask through the condenser. So this this solution should be titrated against a known strength of FAS should be maintained, that will be known. So flask against FAS using the indicator is ferroin. All of you know how to do titration. Okay, so take the 25 ml of that solution and add ferroin indicator, titrate it against FAS solution. So what will be the end point of the titration? It will be green color to reddish brown. So once you get the reddish brown color, stop the titration and note down the reading. What is the reading? How much FAS is consumed to for neutralize the potassium dichromate solution. Okay. Now here, this you have seen. This is the process. First we have taken wastewater, added all the reagent. Okay, and then the solution is refluxed for 2 hours, and then it is titrated against FAS. So you note down that this is called as the back titration. Back, BACK. This is the back titration or titration of the wastewater titration when the sample is taken. Now after you note down this reading, this point, after this point, last point, end point you have got, you have taken down the reading. Now take the same volume of, instead of sewage water, take only distilled water. Note it down. First is 25 ml of sewage water taken. Next titration, do not take the wastewater or sewage water. Take only distilled water. If you have taken 10 ml of wastewater, then take 10 ml of distilled water. If you have taken 25 ml of wastewater, now take 25 ml of distilled water. Add all the reagents. Add all the reagents here, like dichromate, sulfuric acid, mercurous sulfate, and silver sulfate. All the reagents. Shake well. Reflux for 2 hours. Cool down. Then titrate against ferrous ammonium sulfate solution. Okay. So this is called as the blank titration. So here two readings should be taken. One is the blank titration. Let the value be A, and the back titration, let the value is B. You note down these things. Okay, then calculate. This is the calculation part. Calculate the COD in mg per liter. Again, the unit to express COD is mg per liter. So it can be determined by using this formula. Write this formula. If you are able to see the this screen properly, so formula for COD is A minus B into N into 8000 by how much ml of sample is taken. That you can write as capital V. Okay. So note this down and see that A equal to ml of, or what is the volume of FAS required for blank titration. B is what is the volume of FAS required for sample titration. N is the N is the normality of FAS solution. Sometimes we write N, sometimes we write Z. Okay. In some books you may get it as Z, and this A minus B you may get as X minus Y, but the things are same. And always remember that A is greater than B. Always A is greater than B. Note it down. That COD value will not come. Okay, the COD value will not come in negative. Okay. Can you see now, Abu Sufyan? Okay, this is, you write COD is equal to, in bracket, A minus B into N into 8000 by capital V you write. Okay. Now see this. Those who could see, write the formula, then I will go to next slide. See it. Now it is clear, Abu Sufyan. Numerical problem on COD. It is clear now. See here, I have written this formula here. COD is equal to A minus B into Z I have written here. Z for the normality or the N, same thing, into 8000 divided by V. V is the volume of the sample taken. Is it clear now? Have you understood? You can message. See, written COD is equal to A minus B into Z into 8000 by V mg per liter of oxygen. Here you read this problem. I am dictating. You can write it. Write the problem. Then you will understand. Write the problem. In a COD test, yeah, there is reason for multiplying 8000 because it is in terms of oxygen. Oxygen, okay, atomic weight, how much? 8. So it is 8 into 1000. It is per liter. Liter, 8 into 8 is the atomic weight of oxygen and 1000 is per liter. To calculate per liter, it is 8000. Right. Write this problem. In a COD test, 30.3 centimeter cube or ml and 14.5 ml or centimeter cube of 0.05 N FAS solution were required for blank and sample titration respectively. The volume of the test sample used was 25 cubic centimeter or 25 ml. Calculate COD of the sample. That got it. Here two values are given. For blank titration, 30.3 ml of FA solution needed. For back titration, that is with the wastewater sample, 14.5 ml of FA solution is needed. So what is A and what is B? And what is Z or normality of FA solution? Put all the values and post your answer. V is 25 ml of the wastewater sample is taken. So V is equal to 25 ml. So write the formula for So write the formula for COD. Write the formula for COD and substitute the values. What is the unit? Unit is mg per liter of oxygen. Mg per liter of oxygen. Okay. So roughly all of you have got the same answer, 252.8 mg per liter. Is that clear? Anybody not understood? So from this numerical problem, is that clear? What should be taken? How is the, yes, how will be this not 255? No, 252. Who has got 255? Karthik. See once again. Okay, so 1 minute. I am going to the next problem. So do it yourself, this problem. Second problem you do. 25 ml of the effluent sample was reacted with 15 ml of. Okay. Okay, go to the second problem, this one. 25 ml of the effluent sample was reacted with 15 ml of 0.5 N K2Cr2O7 solution, and after reaction the unreacted K2Cr2O7 required 20 ml of 0.1 N FAS for reaction. Under similar condition, 15 ml of 0.5 N potassium dichromate solution mixed with 25 ml of distilled water require 30 ml of 0.1 N FAS. Okay, calculate COD. Calculate COD. It is very easy. Just to find out A and B. Which is A, which is B. So many numbers are given. Which is A and which is B. Post your answers. A how much? A is 30. B is 20. Right? Calculated. Post your answer. Easy problem. Babre. Hey, you have not understood anything. 1,600. No, you have not understood. Then you need to 266 also. No. Do properly. Then you need to read the procedure once again. You need to read the procedure once again. What should I do? Should I repeat the procedure once again? Have you written the question properly? No, 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 no one. What is man? Ganga Katti? No. Nobody has got answer. Why? Hmm? I will repeat the procedure. Okay. Okay, I'll have to arrange for one more meeting very quickly. See this procedure. This is the procedure. Nobody has got answer. Nobody has got answer. No, no, Amrutaloni, Karthik, Pavitra, no, 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 not understanding. Okay, so you wait for the next link I am sending. Okay, I am sending next link within 10 minutes. Within 10 minutes, you try to join. Question slide. Question slide. Okay, question slide. Question slide. This is the question slide. I am coming back. I am coming back to you with one more link. Nobody has got answer. Okay, by this time you just watch this video I have sent you through WhatsApp. No, no, Mayur, no, answer not correct.